Hello dear students, this is Dr. Aisha Nazuk here. Today we are going to discuss video number 7 for this playlist on Introduction to Econometrics. And the channel RowHub has by now the people who have already subscribed or the regular viewer of my channel, they are well aware of the fact that there are a couple of, in fact many playlists on this channel that range from introductory statistics to econometrics, from probability theory to software help. So I have technical videos on software help. I have some general technical videos like how to download books and how to make a Google Scholar account. So these are some of the type of content that you can find on this channel. Apart from these academic videos, I also have a playlist about the human behavior and positivity. I have an interesting playlist on comedy on as well. So this channel is sort of a holistic portal or a holistic hub where you can enjoy different type of content. So today's video, as this is about the course Introduction to Econometrics, so today we are going to do an activity on computing the regression betas, their variances, coefficient of determination and coefficient of correlation. So by now, if you have watched all 6 videos before this one, because as I said this is the 7th video, so if you have watched the earlier videos, by now you have got an understanding about linear regression, the bivariate regression, and the derivation and the theoretical formulas of the regression betas, that is the intercept and the slope. We have also discussed the variance of regression betas and the coefficient of determination and coefficient of correlation. These last two aspects will be covered in video number 8. So for now, if you are unable to relate to the concepts discussed about the coefficient of determination and coefficient of correlation, if these terms are new for you, don't worry, these will be covered in video number 8. But the concept of regression betas and variances, they have already been covered. So you can say that this part of the title has been already covered in previous videos, whereas this, let me highlight it using some other color. So this turquoise, or sort of a this is turquoise color. So this turquoise highlighted contents, they will be covered in video number 8. So let's start this lecture. This lecture is based on table number 3.2 on page number 79, and this is relevant to Gujarati and Porter book, 5th edition. As you know that throughout this playlist we focus on this econometrics book. I have repeatedly informed all the viewers that this book is easily downloadable from the Genesis library. So you can download this book from the Genesis library. And if you are not aware of the Genesis library and how to download books from there, you can watch my video that is specifically dedicated to the use of Genesis library. Regarding the data sets of Gujarati and Porter book, I will upload a URL. In fact, I will post a URL in the comment section of this video from where you can download different data sets of this book. So let me show you the layout. So this is the URL. As you can see that there are different table number mentioned along with page number, and this is 5th edition book, so the same book that we are downloading or using. So you have different data tables along with page number. So I will post this link in the comment section so you can use it. Okay, so now referring to the table 3.2 on page number 79, this table, let me show the table on page number as I said, let me refer back just a moment. So page number 79. So we have to go on page 79. Let me skim through this book. Yes. Okay, so this is page number 79. So let's read the statement here. So I've actually copied the same statement on the PowerPoint just to show you that this is from the page 79 of the book. So this this statement, let me make it easy to view. Yes. So we know that among many other variables, education is an important determinant of wages. That is, in simple word, how many dollars you earn, or how many, let's say if the wages are measured in cents, so how many cents you earn depends upon the year of education you have. Although there are many other variables, but education is one of the important determinant of wages. So in table 3.2, we provide the necessary raw data to estimate the quantitative impact of education on wages. That is, we are going to run a regression on which we take wages as a dependent variable and education as an independent variable. So y is mean hourly wage and x is years of schooling. So you have to do these four, you can say four questions related to this statement. Number one is you have to use the formula given below to compute the slope and intercept. If you have watched the earlier videos in this playlist, you know that one of the version of the formula for beta 2 hat, that is the slope coefficient, is equal to this form, where by now you know very well that the lowercase letter are in deviation form. Next we have the formula for intercept. So beta 1 hat is equal to y bar minus beta 2 hat times x bar. So we are going to use this formula, and I'll shortly show you the Excel file where we will use this formula and compute the slope and intercept. And then you have to compute an estimate of the variance of the stochastic error term in the population regression function. So this PRF stands for population regression function. So currently let me just have a quick read on all these statements, and then we will solve this one by one. Number 3 is compute the variance of slope and intercept, and number 4 is to compute the coefficient of determination and the coefficient of correlation. So we have to refer to the Excel sheet titled table 3.2. For my nurse students, I have uploaded this Excel sheet on MS Team, which is a professional portal through which we are connected. The general viewers who are watching this video, they can get this by emailing me at this email ID, or they can directly download this table 3.2 from the URL that I earlier mentioned, that you can download all the Gujaratian portal data sets from that URL. Okay, so this is one of the screenshot of the data file. The first 3 columns that are in yellow highlight, they are part of the given data. In other words, if suppose it's an exam question, and then these 3 columns are part of the given data set. So let's go directly to the Excel file. So here we can see that we have a column which is simply observation number or the serial number. So you can see that the sample size is 13. Then we are given hourly wage and years of schooling. Okay, so this is years of schooling. Okay, so just a minute, I was just trying to show it better, but maybe anyway. So this is years of schooling, or X. Okay, so next we have to all the other columns that are appearing here we have to compute them one by one. As you can see, even in the formula that was given, that we have to find slope coefficient by using the deviation form. So you know that to compute the deviations, we have to find value of y bar and x bar. So we find here x bar. If I double click here, you see I have used the average function, and the C column, and that is the X data, is selected here, and then I'll be able to get value of X bar. Similarly, value of Y bar is computed by using B column, which has the data on Y. So now we have the value of x bar and y bar. So next we are going to find the deviation x minus 12, that is the lowercase xi. Similarly, we will compute y minus y bar and we will call it lowercase yi. So suppose if I double click on this column, you can see that this is x value minus 12, that is x minus x bar. Similarly, if I double click here on the column number E, I can see that this is y minus y bar. So once I have the deviations, what I have to do is to multiply these deviations, because if you see the formula of beta 2 hat, you need the product summation of the product of these deviations. So we have to multiply yi and xi. So here is the column yi xi. Yes, so if I double click on it, you can see that this is a product of deviation of x and deviation of y, and the sum is 131. Okay, so now we have one part of, that is the numerator of beta 2 hat. Now we need the denominator, which is sum of xi square. So I already have the data on xi, so if I want to calculate xi square, that's very easy. I have to multiply it by itself and I have xi square. So now the sum is 182. So I have to divide this 131.786 by 182. So if I double click here, you see I have divided 131.786 by 182 and I get the slope coefficient. So this is my regression slope. Similarly, I can easily calculate the intercept. So let me calculate. If I write here intercept, so intercept is equal to y bar, which is 8.67471 minus slope times, that is 0.7241 times x bar, which is 12. So intercept is minus 0.01449. So now we have the answer for slope and the intercept. So exactly this solution is shown here as well. You see we have the slope beta 2 hat is equal to 0.724 and intercept is equal to minus 0.01. So these are the same values that I have calculated there in Excel. Since this is a very small data, so it's not necessary that you use Excel. You can copy these values on a notebook and then you can manually solve all these calculations and verify that the slope is this and intercept is this, that is minus 0.01449. Okay, so we are done with one part of the question. Next is we have to compute an estimate of let me highlight it. Yes, we have to compute an estimate of the variance of the stochastic error term in the population regression function. Recall that in the population regression function, the error part, stochastic error term, is called UI. So we have to find the variance of the stochastic error term. So you know that the variance of the stochastic error term, it is always equal to sum of squared residual divided by n minus 2. This formula is for the bivariate version, that is when we have one x and one y variable. Later on when we'll do multiple regression, multiple version of the linear regression, then you will see that this formula will change. Anyhow, for now, for the bivariate regression, when we have one y and one x, that is one dependent variable and one independent variable, this is the formula for the variance of the stochastic error term in the population regression function. Okay, so sum of squared residual we need, and then we have to divide it by n minus 2. So if you see, we have to find residuals. For that, first of all we'll calculate y hat, which is the predicted value of y. So you can see y hat is equal to beta naught plus beta 1 times x, where you know that beta naught is intercept and beta 1 is slope. So this is how we have calculated y hat. Next, ui or the residuals will be actual y minus predicted y. So you can see I have subtracted y hat from y here, and I get the residual series. Now I need to square it. So you see, now I have multiplied each residual with itself. So I have the squared series, and here is the sum of the squared residual. So we need to divide sum of the squared residual by 11, and why 11? Because the sample size, as you could see, is 13, so n minus 2 is 11. So once we divide, we get the value 0.90115. So this is an estimate of the variance of stochastic error term in the population regression function. Okay, so next we have to compute the variance of slope and intercept. Now it's very easy. I think you can easily do it. Now you have the value of sigma hat square, which is 0.90115. So you simply have to divide it by sum of xi square. So just a second, I think that I have done it there. So let me show it on the PowerPoint slide here. Okay, so variance of beta 2 hat, as I said, it is equal to sigma hat square, right? Variance of beta 2 hat is equal to sigma hat square over sum of xi square. Now you can easily verify using that Excel file that these are the values. By the way, you might be saying that there is a little bit of a difference here. Don't worry, this is just a minor difference due to rounding off. For example, if you round off the beta 2 value to 2 decimal places or to 3 decimal places, or if you use Microsoft Excel, the answers will be a little bit different, but that's not a point of concern, because the final answers will be almost same. Anyways, next we have to calculate a correlation coefficient, the coefficient of determination, that is r square. You know that the coefficient of determination is equal to 1 minus residual sum of square divided by total sum of square. So what is residual sum of square? It is simply sum of squared residual. And what is total sum of square? That is, you have to take the deviations of y that we have already taken and then square those deviations, and then you do all this calculation and you will get the coefficient of determination. So now you have the Excel file, or you can get it by emailing me, and you can easily verify that the coefficient of determination is this, and if you take the square root of coefficient of determination, that comes out to be 0.9521. Similarly, we have the formulas for variance of beta 1 hat, and we can calculate. So let's see how we can interpret what we have computed. So let's focus first on the interpretations of beta. So we just found out that the value of beta 2 hat is 0.7240. That is, the slope coefficient is 0.7240. So you know that a typical interpretation of the slope coefficient is, first of all, just for a moment refer back to the actual file. Just a moment. Yes, so refer back to the actual file, and for a moment just look at the values of x. You can see that the minimum value of x is 6 and the maximum is 18. So when we will be interpreting these results, actually whenever we use the regression for prediction, keep in mind what is the sample range of x values, because we cannot predict outside this range. So we have to write that within the sample range of x between 6 and 18 years of education, as x increases by 1, the estimated increase in wages is about 72 cents, because the data is in cents. So you can say that with each additional year of schooling, on average hourly wages are increasing by 72 cents. So if for example, if someone education increases by, let's say, 5 unit, then you will multiply 5 by 72, and that will be the expected change in, or expected increase in, the hourly wages. So this is the interpretation of the slope coefficient. Regarding the interpretation of the intercept, first of all keep in mind that many a time the interpretation of the intercept is sometimes, in fact many a time, not logical. For example, if here the value of intercept is negative, which indicates the average level of wages when the level of education is 0. So you may think that this doesn't make a lot of a logical sense, right? Even if someone is not educated, he or she may be able to earn. So sometimes you may not find this interpretation as logical, right? Keep in mind that the more you can say focus is on the interpretation of the slope coefficient, and intercept is simply declared as the average effect of other variables, that is the average effect of variables other than education that may affect wages. Then the interpretation of the coefficient of determination, that is r square, and the coefficient of correlation, that is r, that is the square root of r square. So the r square value is just found that it is 0.90. It suggests that education explains about 90% of the variation in wages. So that is a pretty strong degree of ability to explain the variation in wages. So we know that the maximum value of r square can be 1. So that means that 0.90 is a fairly you can say high value. So this regression line fits the data very well. And that is, in this data set, it seems that education has a significant impact on the wages of respondents. Then the coefficient of correlation, which is the square root of 0.90, comes out to be 0.9521. This will simply tell me you can say that they are positively correlated and highly correlated. Once again, the upper and lower bound for r are -1 to +1. So if the sign of r is positive, that means that the two variables are positively correlated. By the way, there is a full dedicated lecture on coefficient of correlation on another playlist on this channel. I will post its link to the coefficient of correlation lecture in the comment section. So if you are not aware of these concepts, the coefficient of correlation, it's highly advisable that you can first watch that video, and then this activity will be relatively easier to understand for you. Okay, so I'll continue. Just a minor passing note that this example is only related to the case where we have one independent variable. Otherwise, you know that the model of wages may include variables other than education, such as gender of the respondent, because we know that there is a discussion globally that there is a gender differential among wages. Then we have racial differentials and location-wise differences in wages and so on. So, but that will be covered later when we study the multiple linear regression version of the model. Okay, then the interpretation of the standard errors of beta. Actually, if you don't know what standard error of beta, it's simply square root of the variance. So we note that the variance of the slope, or beta 2, came out to be 0.070072. So if we take its square root, this highlighted part, this is called the standard error of slope coefficient. So what's the use of this standard error? Actually, you know that we have established the fact that the regression betas are random variable, because if you change the random sample, their value will change. So suppose we want to give a range within which we can be 100, you can say we can be pretty confident that the actual population regression beta can be contained. So the way people have interpreted it is as follows. That if we assume that beta 2 is normally distributed, then first of all, before I continue on this statement, you can watch the video of Monte Carlo simulation, where I have shown through simulations in Microsoft Excel that the distribution of beta 2 is normal. Okay, so if we assume that beta 2 is normally distributed, then if we draw 100 samples from the population and we run 100 different regressions, right? Suppose theoretically if the population is available and we repeatedly draw 100 samples from that population and then run 100 regression, then 95% samples would have their slope coefficient between this range. And how is this range computed? This is the value of beta 2 from the sample. Just refer back to the results. You see that the value of beta 2 was 0.724 approximately. So we have used this value, the value of beta 2 in the sample minus 1.96. This 1.96 is the value of z alpha by 2 in the normal distribution. So if you don't know what is the use of normal distribution table and how we can find out the values of normal distribution variable using the normal table, you may find this interpretation a little bit of difficult. If you demand, if my viewers demand, I can post another video on using the normal distribution table and how to find this value 1.96. Otherwise you can use online normal distribution calculator to generate this value by fixing the confidence level at 95%. Anyhow, so this is the first term is the result of beta 2 in the sample minus the z alpha by 2 value, which is 1.96, multiply by square root of the variance. So variance was 0.070072. So for the lower bound I am going to subtract it, and for the upper bound I am going to write the same expression with this plus sign. So I get this range. And now I can say that out of 100 samples, 95 samples will have their slope coefficient between these two values. So similarly we can interpret the confidence interval for the intercept. So thank you for watching, and please subscribe to this channel. Consider it as a professional collaboration portal, and you are more than welcome to drop me an email, get connected, and see how we can further benefit from each other's experiences. So learning is a never stopping journey. Keep watching the videos and keep learning. Thank you.